Alright, so this project is going to go over making a refrigerator monitor for temperature. You can buy these online. I'm just going to get that out there. Yes, you can go on Amazon. There are wireless ones. They have screens, alarms, everything's built in. But I like to collect data, and I'll show some of what I do with that later on in the video. But I decided to set out and build my own. It'll be based on the ESP8266, specifically the little Wemos D1 Mini, and just a couple basic temperature sensors and a light sensor. So it'll collect all this information. I've been running a sort of a test setup for a while now, so this is more of a version 2 getting installed. So video will go over just sort of a quick build process, me putting everything together. I'll show just kind of what it looks like, putting it in the actual refrigerator, and then show some of the data that I've collected, and maybe some future plans on what I'm going to do with it. So let's get started. Before I install this, I figure I should show it real quick. So 3D printed a couple items here, got all the soldering and everything done. This will be the actual housing that sits on top of the refrigerator. It's got a little tiny speaker in it. This is to alarm. It'll chirp when the temperature starts climbing, and it'll go into an alarm state where it beeps much more frequently whenever it starts alarming. This is the ambient temperature sensor. This is the ESP8266 that's actually running everything. And if I can get to it, that is the ribbon cable connection that will actually run through this very, very thin ribbon cable that will go through, well, it'll be between the door seal and the door. I'll just put a piece of tape on there to hold it. And then this will just plug in via USB, making this battery powered where it could just run on its own. It complicates things. There's a lot more to think about with that, especially with a refrigerator in the garage. I just didn't want to do it. So this will be the first unit that goes inside the refrigerator. This is where the ribbon cable terminates. In here we've got a couple things. We have another temperature sensor, so this will be the temperature sensor at the very top of the refrigerator. This is the cable termination. This is a light sensor that I've added that can detect if the door's open or not. There will be some items in the code for that. When the door opens, it will decrease the amount of time between posts. It will add, I believe, 5 seconds every time it posts until it gets back up to 60 seconds, and then repeat to post once a minute for the temperature. The reason for that is when the door opens, obviously you're letting out a lot of cold air, you're letting in warm air. You possibly added some items or removed some items from the refrigerator. So it's going to be a little bit more data to graph out over time for a couple minutes, at least after the door opens. So light sensor, temperature sensor, termination. This will sit at the very top. It's ventilated so we can get some air in there, as you can see there, and just a little 3M sticky thing on there. Something else I added to the top piece is a blower fan. When I was testing this, it turns out the temperature between the very top of the refrigerator and the very bottom, it's about a 10-degree difference there. I don't think it's anything with the refrigerator except maybe bad airflow design, but there's not much that I can do about that except add a fan. So the plan is this will terminate at the top, very top inside. This will sit on the side towards the top, and it'll suck in the slightly warmer air. We're talking 42, 43 degrees at the very top, and blow it downwards. So this is just 5 volts. This is one of the other lines on this 8-pin, I guess, cable here. It's just a 5-volt fan constantly on as long as that's plugged in. For the middle and bottom sensors, I 3D printed tiny little cases. I could have made these smaller, but I had these 20 millimeter 3M, double-sided sticky things sitting around. So I decided to just make it 20 millimeters. The little sensor and the PCB board for it is 11 by 11, so it fits with a little bit of extra room, if you can see that in there. but it has another temperature sensor, and this just jumps onto the next sensor. So this one right here with the two cables on it, this will be the middle, and the bottom where it terminates, this is just a 3D printed little piece. I can reuse as many of these as I want. Has the same PCB jumper, just no additional cable. So this whole setup, box on the outside, this sits between the door seal and the frame. Top, fan blows warmer air down, middle, bottom sensor. I've got my new refrigerator monitor set up here. This will be the outside box. I have a magnet that I put in there so it'll stick to the top of the refrigerator. This will be the control box that goes on the inside. This has the light sensor in it, and it's where this cable terminates. It also powers the little blower fan. All of these have double-sided stickies on the inside. This is the bottom sensor, the middle one. It's got the two wires coming out of it. And we will get it installed in this fridge to replace this test sensor up here that I've had going for a while. Nothing to really remove in here. This has just kind of been dangling everywhere. So I will get this pulled out and get the new one put in. Inside control units installed. I'll do a little bit of tidying on the wires. I've got the fan here. This is going to blow the warmer air at the top and try to circulate it a little bit better. There is my middle sensor right there. That's not being blocked by anything. These are just 3D printed little things I threw together in Tinkercad. And then unfortunately at the bottom I've realized a problem installing this sensor is this drawer is going to clearly interfere with it. Even with this wire out of the way, it's going to barely kind of brush by. So that might be a problem in the future, but for now I don't really get anything out of there ever. Like I said, this is a garage refrigerator, so we're going to let this cool down before I plug it in because it has alarm sensors for if the temperature sensors are too warm, and they are too warm right now. So give that some time to cool down, and then I will hook it up and show some of the data it's collecting. The new fridge monitor is hooked up. It is collecting information. You can see here where I had my previous refrigerator monitor, it stopped around 132, and I had everything installed with the new one around 10 minutes later. The only difference between these two is I changed the code a little bit. With the new refrigerator monitor, it does have a door open or door closed, so 0 being door closed. I haven't opened it, but once I do open it, there is actually some code in there written to make it report a little more frequently and slowly go back to every 60 seconds. So we are collecting information here. I shouldn't need to update too much on the dashboard that I have for this. Just to clarify what this is, since I skipped over it, this is Splunk. I run a local instance for all of my IoT. You can use Elasticsearch, whatever you want. I like Splunk because I'm familiar with Splunk, so that's what I use here. So it's just sending, it's got a listener on some port that I configure all my IoT devices to send data to into Splunk here. So I've got this information for it. I will go open the door and close it, and then we'll refresh this. I'll go ahead and click refresh since it's been a little bit since I ran that search. You can see I am collecting information. So a few quick points about the data here that's being collected. So this is just a couple charts of the sensors that are in there. So I have 4 temperature sensors. This is the ambient temperature in the garage. So you can see when night hits, it's been a little cooler lately with it being the fall. And then middle of the day, we're getting up around 75, 77, and today we've hit about 81.5. So that is the ambient temperature just in the garage itself. For the refrigerator, I was looking at the sensors and doing some recording last night. This is the last 72 hours, so you can see some spikes in a couple of the sensors here. And that's when it's, doors open, also getting back down to temperature for a bit. This is when I cut over to the new sensor and installed it. The sensors physically themselves had not cooled down yet, so I have these really big spikes in here. I may actually go delete that data just so it's not there. But everything now is chilled back down and cooling. The new thing that I had and don't have any history for With the new version of this board here, the boards that I had created for this, they do have a light sensor on the inside, and that's that little event down here showing door 1 with door being open. So I could do some calculations and essentially say how long was the door open roughly. As I mentioned, it reports more frequently when the door opens, so when the door's open, I think it's every half second. I have it configured right now. I'm getting a post of information, so it is posting more frequently. So with that, I can use Splunk to say when the door opens to the time you see the door closed, how long was that, and I'll be accurate down to a half second. So I can use the speaker that's built into the board to do some sort of external alert to say the door's been open too long. So let's say 15 seconds, 20 seconds. Whenever it hits that, I can throw out beeps on the speaker. I can also have Splunk configured to email me or do something with the alerted data at that point. So I can either calculate it on the board and send the data to Splunk, which I lean a little bit more towards doing, or I can calculate it within Splunk itself and do something with that. So that's just the current data I'm collecting. The other thing I wanted to show was this is some information from the old sensor, the temporary one that I had in place back in September. I just kind of picked a random day. It was hot back then, so, garage creeping up around, 87, close to 90 degrees that day. And the reason I added the fan on this new version is actually sort of this right here. The temperature in the refrigerator is set to, I believe, 35, 34. So, the middle, bottom sensor, we're doing okay with that. The top sensor, however, is close to 47. Now, this is towards the very top of the refrigerator. So depending on how your refrigerator is built, most of them just let in cool air from the freezer side. And it obviously has some sort of temperature sensor in there. Depending on where it's located, how it's calculating everything, it may think everything's fine, but you do have to realize, hot air rises, cold air sinks. So cold air rises and colder air sinks. That's kind of the way to think of it with a refrigerator. So, I had a 5 to 10 degrees, sometimes 10 degree higher difference in the refrigerator. Again, not a huge deal. It's pretty much just drinks and things in this one. But it is something I kind of just want to see. What does the fan do? Does it help? Is it increase the circulation of the air and get just a more even temperature? So as I collect data here, I'll be able to kind of see, how is the temperature delta between all those. And the last little thing with the data I want to show was just the dashboard for it. So I can select a time range in here. This is just a AI generated image of an open refrigerator, so it's nothing special about it. But here's sort of the sensors in the same charts that you saw on the different panel, and just sort of the average in temperature and what it's seeing. I believe in the past hour is what I have it configured for. So 82 ambient, 39 at the top, 37 at the bottom, 37 in the middle, 37 at the bottom. I have different values set for the green, orange, red, items in here. It's not that important. And then this is just all those temperatures as well over time. So as you can tell, this is around the time I installed the new sensor. So everything over here should hopefully be a little more even than these lines over here. This isn't a huge delta, 4 degrees, 5 degrees between them, except for some of the door open events down here. But I was roughly averaging through the hotter parts of the summer, 5 to 10 degrees difference. So hoping the fan helps, but that is my data right now for my refrigerator monitor. I've got a couple other bits of logic I can build in, such as the alarming, the beeping, and everything. I did think about using the ESP Now protocol for the ESP32 device that's actually running the sensors to send information such as alarms or the current temperatures to another device. And that device would be like on an e-ink display, and I could have it on the inside somewhere just so you can see it as a glance, you can alarm, things like that. But, at some point it's just sort of overkill. You can obviously buy refrigerator sensors and monitors on Amazon. They're not that expensive. This was just sort of a, can I do it? You know, what sort of information can I collect here? It's got the 3 different sensors. It's expandable. I don't know how many of those little Dallas temperature sensors you can daisy chain, but I know it's a lot. So one of the other things I thought about doing was similar to how the flat ribbon cable on the outside runs to the inside, have a flat ribbon cable on the inside run to the freezer section and run the same series of 3 sensors in there. So I could get freezer temperatures, I can get refrigerator temperatures, and just get an understanding of how it reacts to ambient temperatures, things like that. Another thing on the long-term to-do list on the data side in Splunk itself is, I am collecting all of this information. As a human, we're really good at spotting patterns to say, well, spike, we're talking about temperature. That's not great, but it did go right back down. Okay, well, they kind of all did that, and eventually in the future, it will coincide with a door event. So there's, some interesting things that you can do in Splunk itself if you have things like the machine learning toolkit. So I do have that installed as an application here. I might use the machine learning toolkit to say if temperature spikes, door is not open, stays spiked for a certain amount of time, ambient temperature is not spiking either, that's an anomaly. That shouldn't happen. And then, I don't have to just keep tinkering with thresholds and setting things manually. I can collect enough data, since I'm collecting at least once a minute on this, sometimes more frequently, and train a model to detect problems earlier on. This is actually on a to-do list of a different project I have that's doing similar with monitoring my HVAC system, but I have not created that yet either, so that'll be a different project in a different video. So right now, that is kind of complete for this project, and I'm just going to let it run for a while and collect data. I might circle back around to it and make version 2 or version 3, however you want to count it. But that's it for now.